Hi. So we know what a function is. A function is, if a function is from A to B, then elements of A is uniquely mapped to elements of B. Okay, such that all the elements are uniquely mapped to element of B. Now, because of this property, in most areas, a function is perceived as something like this. That this is a function. It will take some input. Okay, and input is given to a function, and based on the input this function will give you some output. Okay, this is how at many places how function is perceived as, that a function takes an input and it gives an output. Now a function is a function is a special type of relation from set A to set B. So this input would be coming from, if this function is from A to B, then this input will come from set A, and the output is any element from set B. Okay. Now at different in different computer subjects, in computer science subjects, we will see many things which are actually functions. For example, uh, in database, we will see that some of the attributes functionally determine some other attributes. There in database, you will see functional dependency, something called as functional dependency. Now about functional dependency, that we will see in the database subject in computer science, but I will just give you a little insight. In database, there's a relational model. In the relational model, the data is stored as tables. You have, let's say, student. Student may have a student name, okay, and maybe school name. Okay, we are talking about, let's say, a government registry of schools all over India. They have a database of, they have a table that stores all the school names. So leave the student, make it student school ID. School ID, school name, branch, and address. Okay. So for every school there will be a record. So one record will contain about every school. Its serial ID, let's say 1. School name, let's say St. Michael's High School. Okay. And the branch, let's say Bihar branch. And then there's going to be some address, say Digha. And then there is another school which is Don Bosco and branch Delhi, and address I don't know if there is such a place or not. But what I am saying is this, that before, while creating the table, the database designer will specify some functional dependencies. And what are the functional dependencies? It's like, if you know what the school name is, then school name and branch. If you know a school name and branch, then the address has to be Digha. So if there are other columns maybe, so if this record happens to come again, if St. Michael's High School of Bihar in Digha, let's say for some other information, if they are more than one row, if after some time also, if your school name is St. Michael's High School and branch is Bihar, then it means that address will be Digha. This is what the database designer have to specify while creating the table. And so the right information is being entered every time. A caution is there. So this is one of the integrity constraint. Functional dependency is one of the integrity constraint. And anytime you insert any value, anytime you insert any new record, that record must satisfy all the integrity constraints. So this that record must satisfy. It will check that okay, if a school name is St. Michael and branch is Bihar, then the address has to be Bihar. So what it means that the school name and branch is uniquely mapped to address. A school name and branch is uniquely mapped to address. Means that for every combination of value for school name and branch, for every combination is uniquely mapped to the address. So address is, there are many addresses, but every combination is mapped to exactly one. So that's why it is called functional dependency. Okay. So this is the application of function in database. Similarly, in similarly, in probability, what happens is, uh, you know a little bit about probability, even if means you have passed 12. So in probability, for a given experiment, there is sample space. Sample space is set of all possible outcomes. Now, what you want to find is the probability of any event. Okay, so an event is any subset of sample space. Now, this is how we look at probability as P is a function. So in probability, you write like this: probability of any event E. So this is a function P. Function P is a function. Probability is a function that takes an input, an event, and it gives an output. That is any number between 0 and 1, maybe 0, maybe 1. 0 for impossible event, 1 for sure or certain event. So any number from 0 to 1 is possible. But it will be any one number, means it will be a unique value. So we say that a probability is a mapping. Probability is a mapping, or probability is a function from this set to this set. So omega is sample space. So basically, actually, instead of all events, set of all events, or power set of sample space. Very simple. Power set of sample space. So power set of sample space is nothing but set of all events. So individual element of power set of sample space is in event. So this is your set. Okay, this is E1, E2, E3, so on, all possible events. So probability is a function that maps, uniquely identifies or uniquely maps any event to a number from 0 to 1. Okay, so this is another area where a concept of function is used. Uh, any other place where functions are used? Okay, in programming languages, you know that a programming language like C programming language, it is basically, in nutshell, it is one function calling another function. So why it is called function? If you look at any declaration statement for any function, it is like return type, function name, and then it will take some arguments. This is more or less what a function, how a function is. So this return type is because when you give these arguments are nothing but input to a function, and function will return something, which means nothing but the output from a function. So the fact that a function from A to B, the elements of A is uniquely mapped, because of this definition, This is how a function is generally perceived. Let me take an example of a function. Let me take a set A and set B and let me show how a function is there. Let's say set A is, let's say set A is 1, 2, 3, 4, 5, and you have a set B that is 1, 2, 3, 4, 5, 6, so on till 25. Okay, and what is the ruling condition? So if function is a f that is from A to B, okay, and what is it? Such that f of x is equal to x square, then this is a function. So how every element of f is mapped? So how do we write? What is the explanation? What is this? So look at this symbol. This is how we explain this template. Okay. Here what comes is your input, and using this formula you get the output. So I can, so it's like you give x, function will, now function will use this f, the rule on this x. You give x as an input, function will use the rule on this x, and what the output is x square. So the rule is x square. So f of x means x square. So what is f? If f is a relation, you know that. So f is equal to 1 and 1, 2 and 4, 3 and 9, 4 and 16, 5 and 25. This is your f. Now if the question is that what is, if it is asked what is f2, then what is f2? It means that 2 is the input, and now you will apply the rule f on this 2. So by applying rule f on this 2, what you get? You get 4. Okay, and so this is a representation. So f2 is equal to 4. Similarly, what is f3? f3 is equal to 9. f4 equals to 16. f5 equals to 25. Let me say there is another relation on A to B only. Okay, and how elements of A and B will be related is A belonging to A and B belonging to B. A is related to B if A is a factor of B. Okay, so this is your set. This is your set A and B. This is a function that is defined on A to B, and this is one relation that is defined on A to B. So what are the ordered pairs of R will be? So 1 is a factor of everything, right? So 1 1, 1 2, so on 125. Then 2 2, 2 4, 2 6, 2 8, so on 224, right? 3 6, 3 3, 3 6, 3 9, so on 324, 4 4, 4 8, 4 12, so on 424, and then 5 1, sorry 5 5, 5 10, 5 15, so on 525. So this is your relation R. Now if I ask you what is R1, what is R1, then just like if you see at a function, for any input that you give, you are getting just one output. Now you are not getting just one output. Okay, so R1 is equal to 1 also, 2 also, 3 also, 4 also, so on, so on, 25. Similarly, for R2, you will get more than one output. For R3, you are getting so many outputs, right? I mean, 8 outputs, looks like 3 as a 24. Similarly, for 4, you will get 6 outputs. For 5, you will get 5 outputs. That's why carry forward on calculus, we will stick to the function. Okay, now in the next video, we will see the different types of mappings on a function. Thank you very much.